Hello class, for today, I want to go over the answers for the worksheet assignment that I have given you. Um, of course, you can take this and you can just copy and paste it, but what eventually comes it down to is that I would like you guys to solve these questions on your own and just really verify the answers with me from this video. Um, for number 1 through number 7, we're all consistently been talking about expected values for some time. Tomorrow we'll do a review and then we'll take a assessment on Wednesday. It will incorporate everything that we have been talking about with expected values only. So don't expect like questions from permutations or combinations or things like that. Number 1 says the expected payout for each play of a Carnival game is 0.15. If each game costs 0.50 to play, what is the Carnival's expected gain per play? So for this one, the payout is 0.15. If each costs 0.5, that means you lose the money, so you want to think of this as a negative number. What is the Carnival's expected gain per play? Well, if it costs you $15 to play, or that this is the amount that you can gain, but it costs you 50 cents to play it, then you just simply have to add those up. Remember, the expected value, the formula is always probability times the corresponding value. Probability of the corresponding value all the way down to this. For this case, what is the probability that you might ask? Well, simply there is none. So you just have to simply add the values together as if you're basically adding the value P1, not probability, value x1 plus value x2, which is positive 0.15 and negative 0.5, which gives you negative $0.35. What is the Carnival's expected amount of what is the Carnival's expected gain? Well, that means you're going to be losing money, about 35 cents per game. Number 2, a tile is drawn from a bag at a random and then replaced. The probability is drawing a blue tile is 80 and the probability of drawing a red tile is 20. What is the expected number of blue tiles in 25 draws? So in this particular case, it means that if you were to draw one tile, the chance of it being blue is 0.8. And for 2 tiles, let's say, you get 0.8 plus another 0.8, so it's 2 times 0.8. If you do it 3 times, it's 3 times 0.8 and so on. So if you're doing it 25 times, that means that you simply have to take the probability of 0.8 to multiply it by 25. So that's just as simple as it comes, and then it becomes 20. So out of these 25 draws, about 20 of them would be blue. And if you were to do 20 out of 25 in the calculator, you will get 8 out of 10, which is 80%. Next question. A 10-sided die has a number 0 through 9 on its 10 faces. What is the expected value when rolling a 10-sided die? Don't ask me how a 10-sided die would look like. Just use your imagination. But this is an expected value outcome where you have to multiply the value to its probabilities. The probability of each of this 10-sided die will be 1 out of 10 because each of them has an equal sided length. So that means that I have to multiply the value with the probability, and you have to consistently do that for every single one of them all the way until you get 9 times 1 out of 10. Well, in a sense, if you do this a little bit quickly, what I'd like to do is I like to just factor out the 1 out of 10 out from every single one of them and just do 0 plus 1 plus 2 all the way down to 9. Because if you were to redistribute them, you go back to this. Either way, if you don't have any idea what this is talking about, then just add this part up because that's the same thing as what we have done in the formula up here. So I'm going to do add up all those values and then divide it by 10. So my expected value that I'm going to get when I'm rolling this dice is 4.5. Number 4, a bag has 6 marbles, 6 red marbles, 3 blue marbles, and 1 orange marble. In a game to raise money for a class trip, parents pay $5 and pull a marble randomly from the bag. The payout is $10 for pulling an orange marble, $4 for a blue marble, and $1 for a red marble. So parents pay $5 means that you lose the $5, right? You want to put a negative sign in front of it. So if you have a 6, 3, and 1, that means I have a total of 10 marbles. And the chance of you pulling an orange marble would be 1 out of 10. But the value of that would be $10. The chance of you pulling out a blue marble would be 3 out of 10. but the value of that is $4. And the chance of you putting a red marble is 6 out of 10, but your payoff is $1. So then these are your expected value outcomes that you're going to simply add them up. So it's 1 plus 1.2 plus 0.6, which gives you 2.8. Now, if it costs you $5 to pay, you have to add the amount of expected value of the payoff for this game and the amount of that you actually have to pay to play this game, which your overall outcome will be negative 2.2. So you're losing money. You're losing about $2.20. An insurance company offers two policy options. A motorcycle owner can choose an annual premium of $500 with $600 deductible, or an annual premium of $900 with $100 deductible. Suppose that the probability that a motorcycle will be damaged in a given year is 20%, and then if the motorcycle is damaged, the cost of repairs will be about $800. Which option has the least expected cost for the motorcycle owner? Now, this $800 really doesn't make any sense. It doesn't really matter because you have a $600 and a $100 deductible. It means you're only eligible to pay off for that much. Let's consider the insurance premium A, where you're supposed to paying $500 of a premium with a $600 deductible, which means only about 20% of the time when you get into an accident, this is what you have to account for. So it's 600 times 0.2. Insurance company B says, okay, well, you're going to pay $900, but then you're going to add $100 of deductible and 20% chance of that actually happening. So once you type that into your calculator, this one you get 500 plus 120, which comes out to be total payoff. The amount that you have to pay is 620. This one you actually have to pay $920. So if you're a consumer and if you wanted to get into, let's say, which option has the least expected cost, you will say insurance premium A, and the expected cost would be $620. Number 6, a ski resort, there's a 30% chance of snow for the next 4 days. What is the probability that it snows 0 days? Okay. Well, if the probability that it snows 0 days would be 0.7, because there's 30% chance of snow, that means 0.7% chance of not snowing. So for 0 days would be 0.7. For 1 day it would be 0.3, because that's 30 days. For 2 days that would be 0.6, because you just have to keep on adding them up. 3, 0.9, 4 days, 1.2. Last question. The probability that a plane will arrive on time from airport A to airport B is 0.625. The probability that the plane is 1 hour late, the probability that the plane is 2 hours late, we have those respective probabilities and the amount of time that you're going to be, that plane is going to be late by. This is 0 hour late, this is 1 hour late, and this is 2 hours late. What is the expected number of minutes? That was the key. So you're going to do 0 times 0.625. Remember, the value times the probability times the value times the probability times plus the value times the probability. And let's say I do that, this just becomes 0 plus 0.25 plus this would be 0.25 once again. That would be 0.5. That's 0.5 hours, which means it converts into 30 minutes. Okay. Now remember, this is a video just really meant for you to just watch and understand how to do each of these questions. If you're able to do all these questions without really looking at the video and do all these by yourself, then you're in very, very good shape. You should be ready for the quiz on Wednesday. Thank you. Have a good day.